Hey, Raffaele. Hey, Raman.
Oh, it's great to be here again in .next. I love this conference. How are you?
Oh, great. And really happy to see you. Always.
Okay, so I hope that all the attendees are very, hot and ready to start because I am super excited about interoperability. You know that I love low-level stuff. I love to do nasty stuff with the code. And so we have a lot of things to see, a lot of demos. And what do you think?
It's quite interesting topic, and for me it's always kind of, I don't know, not even complicated, but tricky. So it's hard to, I don't know, to get all the details. You always forgot something, there's always some unexpected bugs and so on. So it's always interesting to hear something on the topic because there's pretty much chance to know something new, to know some new tricks and ways to interop.
Absolutely. And I mean, this is just the beginning of a new era in interoperability because there are new things coming out. And I really wanted to talk as soon as possible as they are becoming mature enough to create something that can be used in production and that can really be used to ease our work in everyday job. So I hope you really will enjoy this presentation and there is a lot of code, so be prepared, stay concentrated because there is really a huge amount of stuff.
Awesome. So, should we start?
Okay, let's go. Okay, welcome everybody to my new .next conference talk. This time is about interlanguage interoperability. I wanted to show you what is coming in the interoperability space. I mean, there are a lot of things happening out there. And since I at least mentioned something in the last edition of .next, I really wanted you to give a full explanation of what's happening there and what's new that is super exciting on our side in order to leverage those technologies that are coming and ease this work. So let's begin. You will know me. I'm Raffaele. I'm a speaker from a very long time, an MVP and so on. But I will skip this one. You have seen too many times my introductory slides, so I will skip that. What's interoperability? Interoperability, according to the dictionaries, is the ability of computer system or software to exchange and make use of information. What is that in IT? When we want to exchange something between two languages or two different frameworks, is the ability to make a call. And as soon as we know the entry point in order that we want to call to exchange the information, we want to make use of that data. And I can send some data on the other side, and I want to receive these other data from our side. And this means basically marshalling, so exchanging data. And this marshalling in the context of today is something that happens in process, of course. We want to be as fast as possible in exchanging data with an in-process component that is on our own. And on this side, we have several possibilities. I mean, we have a variety of operating systems. So we cannot stay anymore just on a single one because more often our software is required to run on several operating systems. Of course, we can create different software depending on the operating system we are running into. But if we can find something that is common and run on over them, of course, it's better. And the second problem is that we have a variety of languages. So we are in .next. So we want to talk as a .NET first. So .NET is our main actor. And of course, we want to talk with C, with C++, and we have to make the distinction between C and C++ because they are very different languages. And also Rust, because Rust is an emerging language that is very important on the low level. I mean, we can compare Rust with C, but it's kind of safer C. Is a kind of C that gives you the ability to protect from memory corruptions and so on. So I am not an expert in Rust. I just started a while ago in poking my keyboard and experimenting, but I really love the idea that you can be safer. And of course, the third problem is that which are the APIs? So at the very beginning, we started with PInvoke, so we know. So the central one, the C language, the C programming language, is the one that everyone adopts for historical reason because it's a long-dated boundary. And but we have other possibilities, and later on, I don't want to spend too much time, but if you're interested, of course, we can during the post conference. There was a commission, the DCE RPC commission, that created a language, that interface definition language, IDL, that describe the thing that cannot be can be exchanged, declared with the C exports that normally we use. And the evolution of this first draft was the COM specification, and later on this evolved in a very similar contract that is the one that WinRT adopted, and now is evolved because it's changed a lot and is no more the same WinRT definition that we use there in Windows 8. I mean, there is an evolution there. We will talk a brief about this, but the agenda for today is observing the many interoperability mechanisms. I want to show you all the possible permutations of this, and this is the reason why I have so many demos. So managed to native and vice versa, discussing the marshalling machinery and what are the opportunities there. And then also the hosting, because we know that .NET code requires the CLR, and so sometimes we need to start from C++, some other times we need to start from .NET, and we have to host the other language and see what are the possibilities. But we also talk about code generators because we don't want to spend too much time in the burden of writing low-level stuff that is error-prone and so on. So we start from the ABI, which is the application binary interface, is the lower level of boundary. I remember a lot time ago when I first started with the C compiler. It was the C compiler for DOS in 5.1, the release. And I'm not meaning Windows, it was the C.1, is the very first. And I found a bug with MASM 5.1, which was the macro assembler compiler. And I wanted to exchange data. I wanted to call a C function from assembly code. And that didn't work because the macro assembler compiler was bugged. And I asked Microsoft to have some explanation, and what was difficult because at the time the internet wasn't still there. And so after escalation, and I had the opportunity to enter my first beta program, the beta program for MASM compiler 6.0. And this is the kind of interface we still have today, where every program language always give you the opportunity to talk with something external. We know in .NET is called PInvoke. We have the same things in Java. We have the same thing in Python. We have the same thing in every language, because before or later, if you have something to call, you want to do it. That's a problem then, but because it is a very weak contract. It just defines the way you pass the parameters on the stack, and there are few, I mean, I don't want to enter the discussion between CDECL and STD code, which is the default in Windows, but I mean, it's a convention in which you put parameters on the stack, then it's up to you. And this is problematic because we need much more information to provide a reliable communication channel between two language. And so this is basically the reason why we need metadata. We need more information. Metadata is information. We need more instruction, declaration, in order to specify how can we pass these parameters, what do they represent. For example, if I pass you a pointer, it's not just a pointer. I want to know how long is the buffer allocation. If I give you an array, I want to know it is an array and how is sized, because if I don't know the sizes and if it's multiple dimension, it's a problem. So I don't know how to handle unless someone hard code the way to retrieve the data by hand, which is pretty cumbersome and error prone. So for this reason, we need metadata. And the IDL, as I said, is the very first step, is the interface declaration language, which decorates, basically, the C contract so that we know more about the parameters. It's an additional information that we bring together with the normal CDECL that we can use. And currently we are using with WinRT the IDL version 3, which is much simpler. And by the way, we will see also the format, which is very interesting for us that are .NET developers. Those kind of information, so buffer size, array length, if I have to copy a buffer or just use it because it's by reference, or if I give you a pointer so that you can write something and I can get back from you, it's super important. And so which metadata should we use? Of course, you can still go with PInvoke. If you want to manually code all the stuff, you can write everything by hand. You know, in .NET, you have the Marshall class to do this stuff. I won't explain this. This is a very basic you can find on my book and on other books as well. So, I mean, that's it. COM is still an option, but I mean, there is a problem with COM because COM use a different type system than WinRT. So you have BSTOR, safe arrays, and very nasty type system that is not the best. But there is a work in progress to port not the entire COM system, of course, but just the way you access the ABI. So just the conventional parameters, the way to talk among components in .NET Core, even cross-platform. And you may wonder why. Basically, the reason is that still today, if you go to the GitHub repository and look up at the code, .NET Core is just continuing using COM internally for certain processes, for certain things. For example, the debugger. The debugger is built upon COM interfaces. And so when I had to write a debugger for my own customer, I had to emulate COM on Linux. And you emulate just the IUnknown and all the stuff, the adref and so on, the query interface. And you don't have to replicate the whole infrastructure, just the ABI. But the IDL is pretty old. Anyway, this works because you can just, you have metadata and you can just add a reference to the COM component and it works and doesn't matter the operating system. And then we have WinRT. WinRT is more modern, is currently for Windows only, even if the specification for the WinRT ABI is something that can definitely work cross-platform. But currently, Microsoft has no plans for porting cross-platform. And we are with the IDL version 3. It is compiled in WinMDs. What are these WinMDs? The WinMDs is a binary format, is the result of the compilation with the middle compiler. And they are in format, we use the same ECMA 335 metadata format, which is, by the way, the CLI, so the .NET specification. So you can open this file with ILSpy, you can inspect the declaration, you will have no body, there is no implementation, but you see the boundary, you see the ABI, you see how the method are sculpted inside the DLL that implements this contract. So it's a good way to inspect them. And also, we have a very new things that will be announced during Build 2021, but is already on GitHub, so it's a public thing, that they also part, let's say, decorated the Win32, the entire Win32 APIs using ECMA 335. And this is very interesting because they just added the declaration, they generated the WinMDs for plain C PInvokes. And this means that you don't have to go to PInvoke.net anymore. You already have the metadata, and so you can generate automatically the code. And this is super cool. By the way, there is this repository, but you don't need to go there and clone or, take the release and use it directly. This is something that is a building block, nothing more. So it's something that is used from other projects that we will see, other libraries that we will see. But unless you don't want to put your hands in the mud, this is something that I did, but you don't need to if you don't want. So how should we go from metadata to C language? The basic idea is that the C language, even for C++, is still weird because you have to care about all the boundaries of the pointer that you are allocating. You have to deal everything by pointer. You have to shape your data. So you want to use C directly, even from C++. You want really to have to deal with objects because the memory allocation, even if it's just a string, have a life cycle. And since we have to care about the life cycle because we allocate the memory, but we also want to destroy it when it's no more needed, of course, we don't want to have, problems. And C++ is a very different language because it's object-oriented, of course, and everything is wrapped. You should never use pointers directly from C++ unless you are really required to. And so there is a kind of mismatch between the two. And even bigger, this mismatch is with .NET and with Rust and with Java and with Python and so on. So we want a natural way. This natural way is called projection. And there are many projections out there that are being created by Microsoft. And if you want to create your own, of course, you can. Projections means just generating the code that adjusts this mismatch. And so from C#, there is a source generator in this project that allows you to generate an entire DLL that contains all the required code that allow you to access the ABI of your native declarations. And if you want, for example, instead we want to use PInvokes, you can use this other project, the .NET PInvoke, which contains the pre-generated PInvokes for the entire Win32 system. And you will see here how many NuGet packages have been created starting from this project. It's huge. I mean, every single DLL with their export is already available on NuGet in order to be used, and you don't have to use PInvoke.NET anymore. And of course, you have also C++. C++, it's a projection makes a very sense, and you will see during the demo, because there is a much better way of accessing the buffers and so on than doing malloc or new and so on. So I mean, that's the old. I mean, in C++, the modern C++ is far better than that. We will also take a look on Rust, because Rust is a very good language for that, and we know that Google is going to give a first-class approach to the Android development for native inside their libraries. So this is a big news. And also Microsoft, you can find on YouTube different videos in where they have declared that want to adopt Rust for the bare metal development, so kernel mode. And this is very good. But there are also other projections. Tim Smith, that used to work in Microsoft and now works in Google, has created the one for Dart. So you also have that. And so we don't need PInvokes anymore. And the life from this perspective is for better. I mean, we have the first option, as I said, is to use those packages from NuGet. And the option 2 instead that I want to show you as a first demo is using instead a source generator. A source generator is something new in C#9 with the latest release of .NET 5 that lets you to declare just in a file you write the API you need to, and automatically behind the scene the analyzer generate the code that contains the PInvoke declaration. And so you don't have to mess anymore with interop services and write by hand all the stuff. The only thing that you need is this, and you are done. I mean, CS Win32 is the package you want to for that. And another possibility, of course, if you are in Windows, because WinRT is Windows specific for the moment, is to use the WinRT API, which is far better because we can automatically generate the interoperability code from any component, not just the Windows stuff. When it comes to the Windows SDK, so if you want to use WinRT to access the location services or maybe the RSS feed and many other DLLs that are there, also to access the camera and many more, you just have to use this TFM, which is new to .NET 5, in which you have .NET 5.0 dash Windows. If you want, you can stop here with Windows, and you make aware, for example, the build system that you are just using Windows APIs, and for example, you can create a WPF application. But you can go further and specify the version of the SDK, and you will be automatically added a NuGet reference with all the required interoperability declaration that are needed to access the Windows SDK entirely. So everything you have in the WinRT space. And this is not restricted to UWP, because now we have the so-called project reunion that is merging the old desktop stuff with the new APIs that are available. And then we can also tell which is the lower bottom OS that we can use from that, or of course we will need some runtime check. This is possible from any Windows application. This includes Windows Form, WPS, and of course console, but there are a few others that are not the main one. The technology used here is basically the same you have when you are using WinUI and the new WebView, which I presented in the past session in .next, is something very useful because you can embed the Chromium Edge component and use it from .NET very easily. But this is not the topic of this talk, so let's go on. So the first demo is Windows API. Let's see how it goes. So I mean that I want to hide a few things. Okay. And I go here. So basically, what do you have? First of all, we will see a standard console. In this standard console, you can see I just have this package reference, which is exactly what I mentioned before in the slide, nothing more. Very simple. I just have not the NET-5.0. I don't need the Windows stuff because I just want to interop with this with the Win32, so I don't have to explain anything to that. And of course, the first thing that this is an optional, you can specify in this JSON file the schema and other few options. So if you want to your PInvoke declaration being public, you can add this, but there are other options that are available for that package. And then you just write this native file where you decide what are the APIs that you want to use inside. As soon as you write it, you will see that those declarations are automatically generated, and you can find the list of the generated files here. This means that I can, for example, create file, and you will see that there is in kernel the declaration that will appear together with the other ones. So create file is here. It just been created in this moment, and there are a lot of other things that I really should not care about. I mean, I don't want even to see them. But for example, if you want to know how should you declare the user32 function that is enum Windows, and you want to get rid of the analyzer, you can just cut and paste this code. And you don't even need the analyzer anymore if you are restricted to just that. And by the way, at runtime, this analyzer will not be copied. So it's a really very, very lightweight approach. And by default, this is the generated inside the PInvoke, the class and the namespace, let's say. And this means that under PInvoke, I have all the methods that I required to create. And this is extremely interesting. For example, if you want to do something more complicated than sleep, I can hit F12. This is my utilities. Okay, this is the code I wrote. And I just had to say, okay, I want to enumerate all the windows and passing this custom parameter. So at the very end, as soon as I have my window, I want to filter them with query with a query made in link, and taking only the one that are really visible and has a non-empty title, and create a list of titles. And for this purpose, my delegate points to a function that is here, that is a private function inside my function, which is something we have seen in past versions of C#. And so I don't have to specify even the I don't need to pass a special instance here that I have to cast 12 params and so on, which can be dangerous for memory. But I can just use this that can see this of the utilities, and this is pretty straightforward. So the first thing I do when I receive an hwind, I simply get the window text length. Again, is one of the API I choose to use. I don't want to allocate any memory for this temporary buffer. So I stack and lock them, and this is the reason why I declared it unsafe. And once I have this amount of characters that I want to allocate, I create the PW string and finally get the window text. Once I have this text, of course, I want to create the final string that will be allocated given the title. And I'm done, because the stack and lock will be deallocated automatically because it's on the stack. And I just have a nice list of strings here. And the result, of course, is super simple. I mean, I don't want to waste much time in here, but let's give it a run if the CPU of my PC allows it. And I mean, it's super fine. It's something that is unbelievably easy. Okay, you see it's compiling, it's running, and these are the titles of all the windows that I have in this moment opened on my PC. And by the way, this is not just the only interoperability that we can have. We can also have a WPF application. And so this time I want to use WinRT, for example, as I mentioned it on the slide, and I can have, I can use, for example, the location I can use the location API, I can use the RRS feed API, and so on. So this is, okay. You see the latitude, my current latitude, and then there is the RRS feed, and this is the feed of my blog, which I didn't update in a while. So I will close this one. Pretty easy. I mean, if you want to go there, it's super simple. We can now go on because, okay, we have seen .NET to Windows using two different APIs. Now, what about accessing custom components? This is the problem. This is why, I mean, I feel this whole topic very interesting. You can, of course, use PInvoke. You can create your own declaration, but Microsoft is currently working to create a generator that works on your custom components as well, not just for Win32. This is much more difficult, of course, because you have to provide some way to decorate your API from the custom components that explain how to deal with those parameters. The problem is always the same since the very beginning. I mean, providing additional metadata that can describe what are those parameters that you want to exchange with the caller. And the other way is, of course, WinRT. And again, we have these two APIs that matches the things. Or, well, we also have COM, but for these purposes, COM is not good. I mean, if we want to stay on Windows, WinRT is better. If we want to go cross-platform, PInvoke works okay, but currently COM works only on Windows, and so there's no clue. I mean, we should go with WinRT and nothing else. So with WinRT, we have different projection generators. We can author a C# component and use them from WinRT, and so expose them as WinRT. And then we can also consume with C# a custom component made, for example, with the C++. And then we also have Rust that is a possible player, which currently is the only projection that is implemented is the one as a consumer. And also we have Python, which is in a very experimental state. This is the reason why I didn't bring to you any demo, which is also very interesting. And is part of the very first project of this family, which is xlang, which contains all the pointers to all the others. And so if we want to consume WinRT C++ components, so basically the things that we use it to do with the C++ CLI, okay, this is far better. This is far better because we can just use ISO C++ language. We don't have any slang in this C++ language. It's required you to install this VS extension because it makes everything much simple. And we used, of course, the C++ WinRT component template, which provide you a skeleton of the component, which is very useful. And on the .NET side, we use instead CS WinRT. And this is basically something that you use to create the projection. But the projection is created automatically. You don't have to do anything because WinRT provides already all the requirement data. So you don't have to bother. And this is really performant because the code is generated ad hoc. We use the very latest opcode that were made available with such as call I, and we use delegate pointers in C#. We use all the stuff that makes these things very, very fast. And so now we are going to see a different perspective. So we are using .NET to access C++ using WinRT. Of course, with PInvoke doesn't make sense. You already know it. It's old stuff. But we want to use a custom component in C++ and access it via WinRT. And so, I mean, we have to open another session of Visual Studio. And this is something extremely new. This was created lately from Microsoft in the last, couple of years, but it is very fresh. I mean, I have constant upgrades. I have constant things that are happening now. So we start basically from these Win native utilities. And I want to immediately show a thing that is very important. When you create the project with C++ WinRT template, you will end up in having a CS project. You may be are not familiar with that, but this app container application should be false if you want to run in the context of the desktop Windows and not UWP. For this reason, you may find that certain API are not available, but if you turn it false instead of true, which is the default, you end up in having the whole WinRT API at your disposal. And the WinRT native utilities are very interesting, and we have different things. So basically, we have different components. How should I declare the component? Well, when you add the component that you automatically have, this is the IDL. This is the way to declare that I want to have a runtime class called windowing, and has a constructor which is public, and this is the API that I want to expose. So I want to expose an iVector view, which is the kind of iList in WinRT space of Windows info, where Windows info is just a structure that brings with you some information. This is an opaque number, so you don't really have to deal with it because it can be useful for other interoperability. And then you have the title, and the information is whether it's visible or not. And if we dig into the component, you just have this that is some STL library, and this is automatically generated because it's GS generated. And you basically have these two classes. I remember you that the struct and classes are the same in C++, so you don't have to bother about struct and classes. This is the constructor, okay? And this is the function. This is the public function. And what we are doing is getting a kind of list of Windows info, is a vector, contiguous space. We call the real true Win32 API, giving the enum callback, which is private. Pretty much the same code we have seen before. I pass as a parameter the address of the vector so that we can fill the vector from here. And then when we are done, we create a result that is made of the view over this vector. And this basically means that this instruction converts the vector into an iVector view or of a view info, of course. And from here, you really use C++, you don't use C. And this means that, I obtain an integer here to know how much the text is long. I allocate the buffer with wchar, which is the default in Windows is wide. And then I get the window text passing this that represents the pointer. As you see, I am not doing any new because it's immediately wrapped inside this unique PTR, so I don't have to call delete. This is a smart pointer that will care about the deterministic destruction. And the get window text, of course, the checking the error, pushing back the result in our vector, and finally we are done. I also have another component here, which is basically a security component, but I want to show first the code here, because the key of the success of this projection is that we now have a managed project that we don't have any need to write code into, which contains just the projection. And we have this item group specifying the package reference to CS WinRT and the SDK contracts. We have some options here that I explained in detail, not truly super important, and then a reference to our C++ component. Once we have done that, we just have here all the declared stuff required from NuGet and the build and where the binary file should go. This is just for NuGet. And for my own purpose, I also created the new spec specifying where these binaries should go inside the package of NuGet. Okay, so this means that this component, which is the one referencing CS WinRT, just create a NuGet package of this native DLL and providing the projection. So at the very end, the managed client, what should it do? It basically have to package reference that one, okay? Benchmark.net was, of course, for me to make some performance testing, and then I just use the components. So I have nothing more to do in this windowing. I just create an instance using C#9, and then I enumerate the windows, which is the call declared in C++. I get the count, I make some filter, and then I print the result on there. And it is amazing. I mean, it's super simple. It's nothing that you have to care of. The other two classes you see here are the benchmarks for PInvoke and Dire and this system. And the WinRT boundaries are very fast. The timing is pretty much the same. You may gain some time in one side, some other in other, depending on the code you write, but it's, it's pretty much the same. At the very end, also the WinRT one will have to access using PInvoke, of course, because that's the way .NET works. And the advantage, the real advantage in having this approach is for doing something that is more sophisticated. For example, and I have shown this already in the past edition, if you want to do a lot of things in C++, just, for example, creating a low integrity process in order that the notepad cannot access any resource from your profile, for example, you have to do a lot of C++ code, and you may find this code already in somewhere in your on Stack Overflow or what else. So you can just wrap this code. And if you want to just wrap the code that you already have, this is the perfect situation when WinRT comes to play, because we have of course the IDL, the edo.h, and so on, that are very simple, and you basically end up in just calling, where is that? Okay, the instantiate the security. You can write to properties, and you can just create the low integrity level process here. So it's super simple. Let's go on, because I want to show a lot of other things. So if we invert the actors, and if we want to C++ to call .NET using WinRT, what should we do? In this case, you have to author a component that allows to expose a class library as a WinRT component. And C++ start the process and have to host the CLR, which is something that you don't want to mess around, of course. And if you want to take control of it, there is another technique that I will show later. But in this case, you don't have to bother at all, because it's already prepared from CS WinRT. And you must be packaged. You must be the components must be kind of packaged as a NuGet in order to include the Microsoft libraries that I will show in a moment. And this is fundamental. Since you have to host the CLR, you have to specify somewhere to C++ which version of .NET you have to host. And this is the file that I shrinked a little bit in JSON that tells those DLLs that you bring around how to start up .NET. And you can also give many other options about the GC and a few others. And also, you have to add a manifest to specify which are the entry points, the equivalent of the main, let's say, but for components. So you have to specify which is a component. And the component, of course, in our case is query catalog, but can be many others. You can put multiple components there. And so let's immediately see this code at work. And so I will close this again to avoid wasting memory, because streaming and debugging together is something nasty. Very, very nasty. So in this scenario, we have very different things that we can do, okay? If you want to take control, of course you can, but I will show the simplest way to do it. So I will start from .NET. And in .NET, you basically have a simple class library that is specifying the SDK in Windows, because we are WinRT components. You can specify, as always, some CS WinRT parameters, okay? And also, we have this that is the NuGet manifest. I have a strange way to increase the package version every time using the current date time. And this is the post-build action to copy a few files in the Rust environment. So this is not really relevant, because it's just something that is useful to me. But the most important thing is this one, CS WinRT. And then we have several components. They are all pretty much the same. I will show you the most complex, because I mean, You are not beginners. So this is a query catalog. A sealed class is a requirement for a WinRT component. I faked a kind of repository with few things and I have a selector that I use. This name projection is because of the select. And I have in my C++ component, you see here the CD catalog. It's an XML repository of compact discs, music, the one that no child knows anymore. And then the make query symbol is like the singular default, and the make query multiple is like the to list, let's say, okay? So I'm basically parsing XML and returning results. I don't want to waste time in showing this because it's pretty straightforward, okay? So the component has nothing special. I mean, I just use what I want. I take care, of course, I have to use types that are well known on the boundary, of course. I can use also complex types, of course. Yes, you can. And then we go to main. And main is very interesting in C++. We start from here. We don't, if you are an old guy, you will remember co-initialize, co-uninitialize. You could do this with Windows RT at the beginning, but with init department, you don't need this anymore because the projection that has been generated with CPP WinRT in order to use our component is smart enough to know that this should happen, and it will code by itself. So we create a calculator. We don't need new because C++ is a value type of language. So everything is by value. And so when I declare this, is automatically allocated. We can call add, okay? We can echo something and receive a string. We can test the alarm F12, and we see that I can play with this alarm that is a managed component, and I send and receive something. I declare a handler within this lambda. It's a C++ lambda, and I have the sender, I have the arguments from which I have the arguments, but I use the sender to send and receive a message again, and then I will print the message here, and after having declared the handler, I subscribe the event. And once I have done that, I start with the timer because I also support events. And that's it. I mean, there are many other things I can do. I can query the catalog. I can obtain a list, and you see that I have an I-vector view of H string that is automatically generated as an outcome from my list of string that I had on the other side. This is all automatically generated code, both from here to expose and from C++ to have the client. So you have two generations at once. And I can start this. And it's straightforward. I mean, I just had to focus on the real business-oriented thing. I don't have to waste time to do anything else. So I have the subscription, the query, I have the query multiple, I have an alarm playing, and so on. So it worked very well. So, and this is an additional thing that is extremely interesting. But the fun comes to play when I want to replace C++ with Rust, because now I can open my Rust client console, which is an additional project inside the same solution, but I prefer to work on this using Visual Studio Code, where, I mean, I have this SRC contains the sources. The target is the outcome. You don't have to care too much about it. The TOML is kind of proj that specify the binding that you want to use, and so on. And you have this special library which is the version 0.80 of the projection that are created from Microsoft. And inside the bindings that you see are referenced here, I have to specify what should I project. And I say I want everything I have in my .windows. And in my .windows, there are the managed component IDL, the WinMD, of course, the compilation, and the binaries, which are the three Microsoft things. So the DLLs that provide Microsoft with the CS WinRT, and of course, the JSON specifying the version of .NET. And of course, I also have the manifest, which is copied automatically in the target. Once I have that, that's simple. I mean, simple code. Not that simple if you don't know Rust, but I am not proficient as well. So I have kind of use namespace, okay? That's it. I specified also the bindings I want to use, and I get the current directory. This unwrap is something that every call wraps also the error code, so I have to unwrap, and if it's bad, it will explode. So this is not the best way to manage the errors, but I mean, I wanted to make something that quick and dirty. I created a calculator and I make the addition, and then I have the echo and I have an echo of component. Let's go to the alarm component with the send receive again, and I have the handler, the event handler, and this is the way I have to write the event handler, which is not that bad. And I use the sender from there, and I use the arguments from there. And then I subscribe the event. I sleep for a while, and meanwhile the alarm will hit, and I will receive this message maybe a couple of times, because yes, 200 milliseconds. Then I remove the event, so unsubscribe the event. I read the XML from string, and I create the query catalog. I make the single query, the first or default, and this is the to list, and I write all the items. So let's see how it works. If I Argo run will compile and run my application, and you see the calculator, you see the echo, you see the alarm coming here a couple of times, you see the catalog, and this is the single result, this is the multiple result. So it's really amazing how you can jump to another language, and since we have the projection generation, we immediately can use all this stuff, and is super amazing. So I want also to close this one so that we are ready for the next demo. And what about going cross-platform? And this is stuff. I mean, I don't mean that you need this, but I wanted to show that it's possible. Of course, the API is poor because currently we only have PInvoke and also reverse PInvoke, which is a very old thing that I gave a talk in like 16 years ago. I don't remember when. And this is super cool because is the ability for .NET to expose entry points that can be called like C decal, so like export C exports code. And you can do it, absolutely. I did it several times. So the marshalling option 1, that is the one that is less burden, is a static .NET method that you want to expose to the external world so that it can be called from C++, for example. And then we can use marshal attributes to obtain automatic marshalling, basically the same we already used for Win32 and all the others. So all the kind of attributes given for interoperability. The option number 2, that is more performant, but you have to manually care with it and can be quite nasty, is to decorate the call with unmanaged callers only, which says basically, I want this method to be called only from native. And so it is kind of special because it's optimized for external call. And you specify here the calling convention. So CDACL, for example, that is the most widely used, especially cross-platform. And you can only use blittable types, so the one that are staying in the CPU registers and few more. And so you have to manually marshal them, of course. You have to really know your memory in order to do that. But you have many helpers like span of T, memory of T, marshal, memory marshal. We already talked in past versions of this lovely conference. So that's it. And I want to show you how to manually host. No, there is nothing automatic here. So C++, starting booting the process, taking control over the machine, and hosting the core CLR, specifying which is the first assembly I want to load. I manually load it, and then I invoke some code on .NET. Okay, and we can do this both on Windows and on Linux. And I wanted you to show only on Linux because, I mean, I give for granted you will trust me that it can be done also on Linux, on Windows, but it's more fun doing that on Linux, of course. Let's go straight to. Okay, okay. So we have native hosting here. So this is basically a C++ project made with CMake. CMake is a build system, very, very useful in order to go cross-platform, and is fundamental because you have to deal with several different configurations at a time, which requires to change the compiler, to change the way the things are deployed, to inform the compiler that certain declarations are valid on Windows, others are valid on Linux, and so on. So this is basically very, very important. So I will not keep open two Visual Studio at a time. Just for a brief moment, I want to show you which is the DLL that I am exposing. And is pretty much the same. You already know all of this stuff. We have query catalog, which is exactly the same code that we have seen before. But I created a console application with the sole purpose to publish this component so that it is deployed on a folder entirely with all the dependencies and including the .NET. So this means that my publishing structures, you see here two profiles, Windows and Linux, are basically targeting Linux x64. Not only this, but I also deploy self-contained. So inside that folder, there is exactly all the required core CLR stuff that is needed. So I will close this in order not to waste memory for my streaming. I don't want the streaming jump up, and that will be very weird and bad. So I need more memory from my PC. And here we are. I want to enter in the CMake declaration. Of course, you will can give a look later on. I have two different configurations for myself. So this is, for example, the Linux one. I created this that I read from. Okay, I created this from my own library, my own C++ library, in order to specify where the target binary file are published, which is the DLL, managed DLL to be loaded, and what are the methods to call, what is the name, the assembly name, the class name, and the method name. But I hardwired the parameter declaration inside my code, because of course I have no metadata, so I have to deal with the PInvoke by myself. And the native code that I have here, you will see that is not too long. And most of the weird stuff that I won't show here, unless you want later on in the discussion zone, is the hosting code. I created all the hosting code by myself. You can find it here in Xcore CLR helper. It's my code, started from Microsoft, of course, but I wrapped entirely all this stuff in order to be cross-platform. And there is a lot of things, checks and different path separators, the file system library, which is cross-platform, but has some cumbersome things, and so on. So basically, what I do is to create this container that I have this context. I initialize with the configuration that is in the binary. Then I print the configuration so that it's better as nice. And then I have this context CLR, which represents the CLR that is loaded in memory. At this point, I can add the trusted assemblies. This is basically the probing directories. So everything that is there, the CLR automatically know that can load the assembly from there. And my publishing path have to be part of it. I created the one and only app domain because this is .NET 5, .NET Core, and then I invoke the print. Then I load the CD XML and I make the query for the single row, and I can do in several ways with the row PTR, with the PInvoke declaration. So there are few things that can be done. I want to show just one of them, just so that you understand that it's nothing dramatic. This is the modern way from C++ to declare a function pointer prototype. So I can create a delegate, but just by asking the CLR to create a delegate given those parameters and cast it to this prototype. And once I have done that, I can directly call my managed code here. And it's fantastic. At the very end, I will have to, of course, free the memory that has been allocated from the other side. I decided this way, but you can do whatever you want. When there are multiple results, there are arrays, and that can be harder or maybe a little more simple, but it depends on your taste. I mean, you can choose whatever you want. It's just memory, but if you mess it up, you will make it explode completely. So instead of running here from within Visual Studio, I want to run the demo from here, which is the WSL2 environment. And I basically have all this stuff already compiled, and I am on Linux inside Windows, because you know that now is possible, and everything is working nicely. If you look LSLA, you see that there are, this is the basically my executable is big just because it's a debug build, of course. And I mean, it's amazing. I just loaded the CLR. I just invoked the managed function, and that's it. So trivial cases work great. It's really super simple. The PInvoke generation for custom libraries is coming, so you don't have to bother to call your own components, and that's very good. The complex cases should be addressed case by case. If you're on Windows, you basically can use WinRT and you're okay. The Clang compiler provides a parser library. If you want to mess up, like I am doing in parsing C++ declaration, guessing what are the parameters, creating your own metadata, and then generate your .NET code, you're welcome. Call me. We can do it together. And then I have a project that I did a while ago, several years ago, where I did it more or less these things using reverse PInvoke, hosting the CLR, and so on with Node.js. There is some documentation there, nothing more. It's very complex. Probably I went a bit too long. Sorry for that. Thank you very much. I look forward to hear questions from you. I am super excited of being a .NET programmer nowadays. So thank you very much.
Thank you, Raffaele. That was a really interesting talk.
Thank you.
I guess we have not much time for questions. So, Andrei,
sorry.
I guess... Oh, no, it's okay. It's really great because we have a discussion zone. So anyway, we could just move to discussion zone. And anyone who wants to ask questions to Raffaele, please just join us at Zoom call. You will have the link right behind the player. So please just call the big button with Zoom on it.
Which one? Sorry.
It's under the player, Zoom button.
Under the
I will send you the link. I will send you the link.
Sorry, yes. It's maybe in the chat? No.
No. We have. I guess you just don't see player, but that's good.
I probably have hidden the video panel.
It's okay.
That's it.
We will send you.
Okay.
Yeah.
So thanks for it.
Yeah, so Raffaele, thank you very much for the amazing talk. I have learned so many new things, and I want to invite you one more time and all the people in the audience who have any question related to Interop and .NET to the discussion zone where you can discuss all of these questions. Thank you very much.
Thank you. Absolutely.